Okay, we are going live. Hi all, hi all. Hopefully you can hear me and see me. Okay. Hopefully hear me and see me, let me know. I see lots of people in the chat, this is wonderful. Hopefully you can hear me and see. Oh goodness, people are cold in Michigan. Hi Ozzy, hi James. I see both Jerry and Mike, you both are in. Wonderful, thank you. Both Jerry and Mike are moderators. They will be making sure you all are kind and behave well. This has been a very interesting set of solar storms. I know there's a lot of hype in the community right now, and so I wanted to come online and let you know, first of all, it's okay. I promise. If anything, it's actually underwhelming, and we'll talk more about that in a bit. I'm very happy. Good, everybody can see me. There's an echo. Let me fix that. I'm very happy. Good, everybody can see me. There's an echo. Oh, right. Fix that. I'm very happy. This always happens. See me. There's an echo. Oh, right. Fix that. This always happens. See me, there's an echo. Oh, right. Fix that. This always happens. Oh, right. I am trying to find the offending window. I am trying to find the offending window. I am trying to find the offending window. I think I found it. It's Patreon again. Lovely Patreon. It always seems to try to start the feed for me, and I hate that. So, all right, I will start Patreon later. So for those of you in Patreon, I will look at your comments afterwards when all this is finished. Whoops, now I've got a window up I don't want. Okay, let me know, guys, if that took care of the echo. That should have. I do not know why Patreon decides to just auto start. I can no longer have a Patreon window up when I'm with the comments live when I start these feeds, because it just automatically starts the stream. Without my permission, I do not know how to turn it off. So good, fixed. Yes, it was the same problem as we had last time. All right, wonderful. At least we didn't have that hilarious loop that went forever. Okay, good, good. So hopefully, oh my goodness, Terrence, what are you doing up in London? My goodness, it's late for you. Okay, thank you for joining. So what I will do without too much further ado, I will be sure to get to all of your comments and things later. But what I want for those who are late, like poor Terrence, who's actually probably staying up to get some news, I will give you the BLUF, the bottom line up front. So I will run through the forecast really quickly up through the 5 days, and then we can kind of go in more a deeper dive, and then I can kind of rewind some of these slides I have here so that we can talk about it more in depth if you'd like, and I can go into some extra data that informs the choices I've made. And for those of you who've been on Patreon, you know that I said that today is going to be very interesting because I am going to deviate from SWPC's forecast, and you'll see why. It's not a fun deviation. I wish SWPC were right, but I'm afraid they won't be, not this time. So, but we'll discuss that, and you'll see what my reasoning is, and if you think I need to go pound sand, feel free. Okay, so let's begin. So what I am showing is, obviously, this is the Earth-facing disk. I'm rolling it back to the 20th, and the reason why is because I just want to give you guys a feel for everything that has happened recently, right? So let's start with that and start on the 20th. You see back on the near region 3555, back on the 20th is when we had that first solar storm launch. That was mainly going kind of like south, a bit southeast of Earth, but it did have a strong earthward component. We thought that one was going to hit us reasonably directly, but sadly, that one has missed us. I mean, it impacted for a very short period of time. We'll talk about it. Believe it or not, that was the most direct hit that we had. So yes, the solar storm, the first of several solar storms did hit, and it has been reasonably underwhelming. The second solar storm was one from region 3559. It also gave us kind of an eastward directed path, an east, kind of a northeast directed path. You'll see it right here. Wait for it. Bam, right there. Okay, so that was the second one. That also gave, like I said, it gave a partial halo in coronagraphs. We thought that one might give us something, but alas, that one missed us completely. Now, the big story is the one we've been waiting for, right? This is the one that the Space Weather Prediction Center is saying it has yet to hit. That's this big filament eruption right here. In my last forecast, I showed you not just the eruption, whoosh, right there. That was a very nice eruption. And notice it was tied near region 3561, which is the reason why I think this filament actually ended up letting go. I think it would have, if it hadn't been for this region becoming flare active, I think this filament would have hung on a lot longer, because it really wasn't all that. It was relaxing. It wasn't even getting more and more unstable. So it launched because of this region. Sadly, the dimming regions, for those of you who understand how wide these structures get, we look for things for dimming, for darkenings at the edges of these structures. And sadly, the dimming regions were really confined. They were really small. So it was kind of scary to think whether or not this was going to actually clip Earth, you know, from the south, because this structure is clearly going south of Earth. It is still Earth directed, but it's going underneath Earth in a sense. And because the dimming regions weren't all that wide, it really, even though the halo was reasonably large, it still didn't quite look like it may be Earth directed. So it's one of these forecasts where you kind of just, you don't want to scratch your head. You want to make an informed decision, but it's right at that hairy edge of, is it going to be hitting Earth or is it not? And NOAA actually put out multiple forecasts for this particular event. Some that showed it hitting, some that showed not. And is that right? I think it was this event. Maybe I'm wrong. Maybe it was one event before it. Sadly, I could use either of the examples, because the one prior to it, both the one from region 3555 and 3559, they were kind of side-swiping structures too. So all of these structures have not been like straight aimed at Earth and clear hit, all that kind of stuff. It's been these structures that, depending upon how you model it, the structure either clips Earth or it misses Earth entirely. And so when you get into that scenario, it's such a frustrating scenario for forecasters, because we just can't make really clean decisions. So I left it in my forecast. If you've watched my recent forecast that was up just a couple days ago, this was the update I had given at that time, was that this thing was going to be a glancing blow probably on the 25th to 26th. And I will show you the models that have come out since then. They are very consistent with this. It was a very beautiful eruption, as you can see. Again, I'm just showing stuff that I showed before in my forecast. Here is the gorgeous view from LASCO coronagraph. Very, very dense structures. So if this had been straight, a direct hit at Earth, it probably would have given us a decent storm. However, you can see it's going mainly south. And here's the difference image, so that you can see features a lot more clearly. A difference image just basically is subtracting subsequent frames. And so you can see this halo is a partial halo, but, maybe not as wide as we'd like it to be. If you include the shock, there's a shock wave out in front here. You can barely see it. That's what I've kind of colored in, the edge colored in green. This looks like a shock wave out here. It's just a very dim halo that sits out in front of the main structure. So if you include the shock, which then does cause disturbances at Earth, this is a decent partial halo, and it does look like it could actually hit Earth because of the orientation, the direction, and the size of this halo. So that's what informs the models. Again, this is the best we have when it comes to trying to understand where these things are going and whether they're going to hit Earth. But there's a lot of factors. There's a lot of traffic going from from the sun to the Earth that will then, potentially blow these things or move these things out of place or out of the way, and they end up missing Earth. So we'll talk more about that in a little bit. So I'll pause here. Let me let this continue to play. Hopefully this will jump to the next frame here in a second. Okay, there we go. So let me pause on that for a sec. We'll get back to those solar storms in just a moment. What I also want to do, since I had the disk up, I wanted to be able to show you what's going on with these regions, region 3561 and region 3559. They have become flare players. Now, there is some synergy going on between these two regions. So in other words, when one fires, the other fires. It's like they're almost kind of talking to each other. but you'll see paparazzi bulbs flashing back and forth. And also notice that this region, it started becoming a big flare player once it rotated to this longitude. So I'm going to call this a hot longitude. Okay, for those who are becoming familiar with the phrase hot longitude, these are longitudes where there might be Rossby wave or some other activity underneath the surface of the sun. And it doesn't matter if you're in the southern hemisphere or in the northern hemisphere, if you cross this vertical line, which is a longitude on the sun, if you cross this line and you see a region becoming active, then other regions that then cross that line also become active. So as I'm going to forward this, you'll see this region becomes very flare active starting around this longitude. That one does too a little bit. And then of course you see 3559 talking back. Now this region fires off, both of these regions fire off essentially R2 level radio blackouts near M class flare or M5 class flares. This one was an M5 something. This was an N4 like 9. So really close. So those of you dealing with radio blackouts on the day side, yeah, these are the two regions that have been causing it. And recently, as you watch this region continue to rotate to the west limb, it actually begins to quiet down. Okay, you'll see it pop, 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 and then it goes shh. It just kind of begins just over the last 24 hours or so. It's kind of quiet. See right there, it's kind of quieting down. Okay, I think it's moving out of that hot longitude. But that being said, just because this one's quieting down doesn't mean that this longitude stops working. Notice what big region has already been firing big flares and is about to enter that hot longitude. This region may pick up an activity here over the next few days, okay? And it looks like they might be having a 24-hour or 48-hour hot spot where it will rotate through this region here and be very flare active. So we will see if this really is a hot longitude. That's what I'm going to expect. I'm going to expect 3559 pick up in activity while this region continues to quiet down. The fact that both of these regions are near the west limb tells me that radiation storms are a distinct possibility. So you'll see radiation storms. I think NOAA's giving us about a 15% chance for radiation storms. I'll talk more about that as we get to the 5-day. But that is definitely going to be a big issue. On top of that, now, see these? We got dark coronal holes. So for those who are not going to see any aurora because we aren't going to have any really big storms, sorry for the spoiler alert right there, but we do have coronal holes that will be rotating into the Earth strike zone in about 4 or 5 days. So we might get some aurora yet, okay, and possibly down to mid-latitudes, I hope. I hope to make up for the fizzles that we seem to be getting right now. On top of that, look to the east limb, okay? See those bright regions? Do you remember from my forecast last time I bring up JSOC HMI helioseismology far-sighted viewer? Do you remember these regions? I hope you can read the numbers. So we have region 35, 38, I believe, 43, and 39, and 40, and there's also region 41 in there too. These regions were big regions on the sun's front side, 2 weeks ago, and now they are about to rotate. I mean, you'll see them rotate here. They're rotating to the sun's far side. This is the far side in gold. The front side is in gray. So now that they've been going through their far side passage, look at the darkness. Do you see the consistency in the darkness? When you see dark spots, when it goes to helioseismology, on the far side and the dark spots stay, right? They linger. That's how you know those spots are real. It's not just some noise, some random noise in the fluctuations of the observations. So those spots are being very consistent. You see even region 35, 40, and maybe even 41, as well as that cluster there. Those are literally about to enter. Okay, so this right here is region 35, 38, old region 35, 38. This is probably region 35, 40 and 41. As a matter of fact, I will go to, let me see if it'll go. Okay, thank you. There we go. Here's the sun's far side. This is the simulated far side. Sorry, I don't have a title. I probably should have put a title up there. So this is the simulated far side. This is what the far side looks like now, but this is really Earth side view from 2 weeks ago. Okay, that's what we kind of have to do. So here's region 35, 38 from the last time it rotated into Earth view. So here is the cluster. It looks like maybe region 35, 43, maybe that's the brightness that we're seeing in the southern hemisphere, but definitely 35, 38. We don't know if these regions are still completely formed, but I definitely believe region 35, 39 is, and 35, 43 is. So we shall see. And then region 35, 40 and 41, which are over here, they're going to be rotating into Earth view in about probably 5 days or so. These were going to be rotating into Earth view, oh, I don't know, maybe tomorrow. Okay, and I've already seen old region 35, 38 firing flares. Okay, so I do know that they're flare active. They may get even more flare active as they rotate into Earth view. It's hard to say, but that's what we've got. These regions have survived, I think, at least 2, if not 3 far-sighted passages. So these are long-lived regions on the Earth-facing disk. Okay, now let's get back to that solar storm. Okay, so this is the latest from NOAA, the solar storm prediction model. This is Enlil, and we're looking at the solar storm that was launched on the 22nd. That beautiful filament that looks like it was going south of us that I showed that really pretty coronagraph picture of. And it's hard to tell if it's because the halo looks, including the shock, looks like it could be Earth, you know, could actually get Earth really well, like hit Earth pretty well. Not completely Earth directed, but, you know, could give us a decent smack. This is, you know, this is one of those predictions where it's really kind of hard to know exactly, not just how well it hits Earth, like how intensely it hits Earth compared to whether it's just sideswipes or grazes us, but it's also really hard to tell when you get to the flank of these structures like this. It's really hard to tell when their arrival time is. So you're going to see a little bit of a difference between NASA and NOAA's prediction. So this is NOAA's prediction. Again, their model, they have the top panel being density, the bottom panel being velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And I'll see if I can set this thing. If it's not going in motion, I'll set it in motion now. And you'll see that solar storm being launched. Here's my problem. Here's one of my problems. They have this solar storm. Sure, they've got some of it if you look at the north-south cut. So that's a vertical cut right through this plane right here, going cut straight down. That's this, okay? They've got some of it going south, but they've also got a good portion of it going north. That does not feel, it just, from the halo that I saw, it just feels a bit inconsistent. They also have a large part of it going west of Earth. So I think they're overemphasizing that west part of that halo. If you recall in the green, when I was flashing that green on and off on that coronagraph image to show the halo, there was a decent part that was going north, but and west, but I just don't think it was the bulk of the structure. Whereas here, it almost looks like it's the bulk of the structure. So when this structure hits Earth, they have it in the ecliptic plane. It's the western flank of the structure that's hitting Earth. Down south, they've got the bulk of the structure, and that won't be seen in this diagram because it's underneath, it's below the disk. This is the ecliptic plane. It's below it, so you'd have to pierce through the screen and look beneath it to be able to see that structure, because that's what's right here. That's why you're not seeing any of it going east of Earth. But nonetheless, they just have such a strong stripe of it going west that it just kind of concerns me that I don't know, it just concerns me. Anyway, when we take a look at when it hits, they have it hitting on the 26th, I'll say 0500 here. Yeah, I think I have it just stopped here. I'm not exactly sure if that's exact time. I think it was a little bit later, but that's tomorrow or shortly, in a few hours. Okay, and then they have it storming through the 27th, and I think I've paused it here, so I don't think it'll play out. But they have it storming through the 27th, and then it begins to settle down. Okay. Now that's NOAA's prediction. If we switch to NASA's prediction. Well, again, you're looking down at the sun from the North Pole with Earth being off to the right. This panel is the density panel. It's the top panel that equivalent to the NOAA panel. So as we start this model, let's see, will you start? Do I have to click you? No, I better not. I'll wait. Let me just wait for it to start, otherwise I'll skip it. Okay, so now it's starting. You should see that solar storm being launched. Again, in this case, the solar storm looks a bit more like it's going to hit Earth more directly. You do still have a huge swath of it south, but you're not looking at it at the big swath of it going north. The northern edge of it, let me say it this way, the northern edge of it is a bit softer, and it's more, that's the northwestern edge of it. It's a bit wispier in the ecliptic plane. So this to me just feels like it's more indicative, more consistent with the coronagraph image that I saw. But, you know, sometimes you put data in and these models just do what they want. And both of these models, both the versions that NASA and NOAA have, they have different solar wind parameters. So that could buffet things and change things a bit. So they're going to get different solutions just because they're using different, they've got different features turned on in the model. You know, so they're not exactly the same. So that gives us a nice bracket, but when you take a look at the impact time of this structure, and you are seeing it impacting in the south, this is, you know, there's the south here. I've got here's the compass rose. I know it's turned sideways, but that's the way it is. So here's the south feature here, okay? So you're looking at that structure, and then, so it's going to hit mainly south, but it does look like it's got an earthward directed component, and when it hits, it's hitting basically at 1800 UTC on the 25th. So that's already past time, right? That should have hit hours ago. Okay, so we've got something. NOAA's saying that the structure should hit on the 26th early morning. NASA's saying the structure should have already hit a few hours ago. Where do we stand? Well, to be honest, I guess I could do the moon. Yeah. To be honest, I think the structure's already hit, and I'll tell you in the deep dive. I'll show you the data. I think the structure's already hit. I think NASA actually was pretty close to being spot on this one, and sadly, it looks like it's grazing Earth. It's just kind of gone south of Earth. And not only will I show you the solar wind data to bolster that point, but I will also show you cosmic ray, because I'm seeing Forbush decrease, something called a Forbush decrease. That is showing us that these structures definitely are nearby, but I don't think they're hitting Earth. But I'll save that for the deep dive, okay? Because so for those who want to get the money shots and get out, here we go. Okay, so now switching to our moon, we are passing through the full moon phase now, and we're going to be on our way to what, a third quarter, right? And I think by the 30th, the moon will be something, let's see, it's 70%. I think I've got it stopped in here. 73%, essentially 73% illuminated. So you will have, you know, you're still going to be competing with a strong moon. Sadly, with the aurora being as weak as it probably is, at least right now, aurora shots may not be all that great for you. The nice thing is that we are going to be moving to a new moon in about 4 or 5 days. When we start getting that fast solar wind, the moon will be a lot less illuminated. We'll be back, you know, we'll be a waning crescent here. So it might be a much better opportunity for you aurora chasers who are just dying to get aurora and feel like you're being teased until you can't stand it anymore. Yeah, sorry about that. The sun does that to us all the time, doesn't it? Okay, so now we're going to switch to our 5-day outlooks. So taking a look at our solar storm conditions and aurora possibilities over this coming week. We are still on storm watch. We're on active storm watch here for the 26th and 27th. NOAA is, I'm deviating from NOAA. I'm sorry, I didn't put my little asterisk thing saying this is not NOAA's official forecast. NOAA has got us, I think, up at, for high latitudes, has got us up at like major storm conditions. Minor storm conditions for the 26th, major storm conditions for the 27th. I am going to deviate that from that completely. If we reach active conditions at high latitudes, I'll be happy because I think that's all we're going to get. I don't think we're going to even crest over the G0. Everything's going to stay pretty calm. I will still keep the NOAA suggestion of 30% chance of a major storm on the 26th and a 30% chance of a major storm on the 27th. So I'm not going to deviate from there because it tells you when these structures are just such glancing blows, it's so hard to know if they're going to hit us or if they're just going to skim by, right, and just barely graze us. And so that's why there's such a massive difference between what I think's actually going to be the condition and what our extreme condition could be. Okay, so that's why there's that biggest spread. But I would say if you're at high latitudes, just, you know, stay vigilant and stay on storm watch because there is a chance that we will get hit by something. I don't think it's a strong chance, but there is a chance. Then, of course, on Sunday, we should be settling down. I'm giving us about a 15% chance of active conditions. I'm not sure what NOAA had put out for this because I did these 5 days outlooks before they updated their forecast. But it's out now, and I could take a look in the deep dive. I can take a look and talk more about it if you'd like. And then starting Monday, start looking for that fast solar wind. Okay, we have those 2 coronal holes. They definitely could be sending us some fast solar wind. I'm expecting on the 29th, I'm believing we'll hit minor storm conditions at high latitudes, but maybe as much as a 20% chance of a major storm. Now, granted, The storm may actually hit on the 30th. It's kind of hard to tell right when that fast wind will ramp up. But that's my guess. It's, we're out at the edge of the 5 days, so it's a little bit hard for me to make really accurate predictions that far out. But just get ready. I do believe we'll have a better chance for aurora, sadly, with the fast solar wind than we will with the solar storms. Even all that beautiful eye candy we've been seeing and all the hoopla on social media, and we get nothing but fizzles. It's so frustrating. Okay. Anyway, so that's my prediction for the 5-day outlook for high latitudes. Yeah, I know. I wish it would be better. Okay, now moving to mid latitudes. Well, again, I'm deviating from NOAA. NOAA has us, I believe, at active conditions, possibly minor storm conditions at mid latitudes. No, I don't think so. I think we're going to be stuck with unsettled conditions, sadly. But again, I am going to keep NOAA's suggestion that the extreme could be a 20% chance of a minor storm, 15% chance of a minor storm on Saturday. So, if we get hit, we'll get hit harder on the 26th, and then things will begin to settle down as we move through the 27th. Would I bet going out and chasing aurora because of these storms? Probably not unless you're at high latitudes. I think mid-latitude chasers, unless you live under the aurora, probably don't want to take more time than to go out and just check in your own backyard or check the webcams, for aurora. I just don't want you to be disappointed. And as we move through the Sunday, again, we should be mostly calm. And then we should pick up on maybe the 29th. We should pick up because of that fast solar wind. Not sure it's going to give us that greatest show down at mid-latitudes. But again, it could be a little bit more than we expect from these solar storms. I'm only giving us about a 15% chance of a minor storm at mid-latitudes for this aurora, or for this fast solar wind, because the coronal holes, they're not in the right location to give us really super strong fast wind in the where Earth is. Let me just put it that way. The coronal holes are a little too high latitudes. So, I guess about a 30% chance of activity on the 30th, and then things will begin to calm down after that. Okay, so switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting at about the mid 170s right now for solar flux, and this is because we have those big flare players actually that are keeping our solar flux up. Region 3561 is going to be rotating to the west limb. It's rotating almost off the west limb over the next couple days. That's what the dip in here is. But I do believe I'm popping it back up again pretty quickly for two reasons. One is because I do believe there's a good chance that region 3559 will start becoming flare active as it rotates through that hot longitude that we talked about earlier, and also because we have those new regions, or the returning regions rather, rotating into Earth view. I've already seen an occulted small, like a C-class flare from one of those regions, which is old region 3548, or 3538, sorry. And so I do know that it is flaring on the sun's far side, so I am expecting that solar flux to begin to creep back up and possibly get into the 180s by the time those regions are in Earth view, or fully in Earth view. That means that we're going to be sitting at moderate noise, okay? Whoops, I still need a space there. I keep making that mistake. We are sitting at moderate noise and will be throughout the week. Right now, NOAA is giving us about a 55% chance of an R1 to R2 level radio blackout. And this is for M-class flares. And then also, I think we're sitting at a 10%. We might be moving up to a 15% chance of X-class flares over the next few days. I might pull it down just a smidge, but then probably ramp it back up. So I think staying at around 10%, say 10 to 15% chance of X-class flares is probably a pretty good estimate. And with those new regions rotating into Earth view and region 3559 rotating through that hot longitude, I do not want to change. I think I'd stick with around 10%. So we're not out of, we're not completely in the clear when it comes to these radio blackouts on Earth's day side. So amateur radio operators expect it. GPS users, if you're near dawn and dusk, that can be an issue for you. I don't think you have to worry so much about the night side disruptions because the solar storms are just, not going to be that big a deal. Whoops. Okay. And let's see. Let's switch to let's switch now to the radiation storm of polar aviation outlook. Now this is nice because we are quiet right now. We're sitting at the D1 normal range, and this of course is for the aviators. This is at flight level 360. and that's also the S0 quiet range for everyone else. Because we do have that both region 3561 and region 3559 getting close to the west limb, that risk for radiation storms, I think NOAA is giving us about a 15% chance of an S1 to S2 level radiation storm over the next 3 days. I will keep that in through the 5-day because, like I said, I do believe region 3559 will start becoming more flare active, and so if so, it could also launch radiation storms again. And that region, in fact, is a bit more of a flare player than even region 3561 is, because it has fired bigger flares and it is a bigger region. It's a little bit more unstable as well. So frequent flyers, and this does include aircrew, you're in the green right now, okay? But keep your eye on those ICAO advisories, because if a radiation storm hits, you know, a big solar flare hits, obviously communication issues, and a radiation storm means issues for you over the poles. And, you know, plan for this in your flight plans if you need to. Okay, and I think that is it for my BLUF for the 5-day. Hopefully it didn't go too long, but I will pause here and answer some questions that you guys might have, and then we'll jump into a deep dive. Does that sound good? As a matter of fact, what I might do is I'm going to go back to my, let's go back to the sun here. And what I might do is actually just, whoa, is it staying? Okay. I'm actually going to show you something cool. Look at that, guys. You've got yourself on here. I can talk to you now. I can point out stuff. Hopefully you appreciate that. I think it's going to update. We'll see how well it updates as new stuff comes on. So questions. Let's see. We need solar flux higher. Well, GPS users would disagree with you, so be careful what you wish for. Too much social media makes the storms shy. Yeah, well, I tell you, you'll see they're not shy. It's just bad aim. The sun is just tossing them to the east and to the south of us. That's sadly the way it is. Okay, let's see. It's cloudy. Yeah, I've heard a lot of people. Who is this? This is James. James, I've heard people talking about it being cloudy in lots of places. There's just not a lot of clear skies. So those of you who've been clouded out and thought you were going to miss a fantastic show, nope, you're fine. Here was me thinking when the first solar storm launched, because it just looked so good and it launched really fast. I went, ooh, this looks like a G2, possibly G3. We get nothing out of it. It's like, oh man, talk about egg on my face. Good night. Oh, well, this is the state of you know, space weather forecasting. What can I say? Okay. Let's see. There are Aurora cams on YouTube. Yes, Teresa, you're absolutely right. I love the concept of this channel. Well, thank you, John. I appreciate that very much. Let's see. Yes, Space Weather Live has an app you can get alerts from. Yes, Space Weather Live is a fantastic resource. I think those guys are just wonderful in what they do. So if you have it, and I have supported them in the past. So if you are so inclined, they are wonderful. And it's even translated in a lot of languages. So I definitely use it. I even use it in my teaching the SWEN program, because they've got just so much good stuff in there. So it's an excellent resource if you have not visited Space Weather Live. You all should. Okay, I'm seeing, let's see, any questions? You're the best, Dr. Scove. Thank you, J-Dog. I appreciate that. Are solar flares trending up? Yes, they are, Jason. They are trending up mainly because, well, and it depends upon what you mean by that question. If you mean, are they trending up because we're getting near solar maximum? Yeah, they are. And I think we're going to see more solar flares as we crest solar maximum and go into, you know, just post the peak of solar max, just because of some papers that Owens et al. Have done that have been very, very interesting, how different numbered cycles have a tendency to be more active on the ascending phase or the declining phase. It's very, very interesting some of the work that they've done. And I've definitely seen some of that, at least with the most recent cycles. So this, if their analysis is correct, then we will be seeing more activity on just past solar maximum with this cycle. Just like the previous cycle, we saw a little bit more activity just prior to solar max. So it's quite an interesting phenomenon. We don't understand that yet. So, Oh, Savannah, thank you. I appreciate you. It says your channel just got suggested for me, so I subscribed. That's kind of you. Okay. Why have we got a hole in the sun, Andy? We don't have a hole in the sun. We call them coronal holes because they look like holes, but they're really not. In fact, if you look at the sun in particular wavelengths, you don't see the holes at all. It's just that the sun isn't emitting light in certain wavelengths. Like this, I've false colored this, so this is actually what you're looking at is a composite. In this particular case, you're looking at a composite of 211 angstroms and 131. I've just turned them. I just turned 131 red, so that it blended better with 211. And this is the kind of a pinkish orange sun that came out. And I went, ooh, this looks good because I can see both the coronal holes and then I can also see the solar flares. And the colors didn't clash with each other and fight each other. So that's why if anyone's going, what wavelength of light is she looking at with the sun? I've never seen this before. It's a composite. It's a composite. Because when I do these briefs, I want to be able to get a lot of information to you quickly. And so it's easier to not have to switch colors. Okay. What's the 360 in the flight level? That is at 3,600 or 36,000 feet. That's because that's pretty much the cruising altitude, or right around the cruising altitude of a lot of commercial aircraft. So it's a nice way of telling aviators in very basic, I mean really rough terms, what the radiation levels are. It doesn't tell them anything in terms of latitude. I mean, it really is extremely rough, but we kind of look at this over the poles. So some of the most nasty areas to fly would be over the poles at, above, let's say, 40,000 feet. And as you go higher, I think as you go up to about 90,000 feet, the radiation doses just keep rising until about there. I think 90 is about where things level off, and then as you get higher, it actually dies down a little bit. It just has to do with the way our upper atmosphere is designed, is the chemistry and dynamics and density of the upper atmosphere, but and really the high energy physics of the upper atmosphere when you talk about it, the way cosmic ray showers are formed and whatnot. There is a peak it doesn't just keep getting higher the higher you get, because the cosmic ray showers actually have to happen. And if you don't have enough atmosphere, you're not going to get a cosmic ray shower because it's nothing to hit. So it's a little bit complicated. I might explain it in a mini course someday, but not really appropriate for a forecast. But that's what that's for, so that pilots can understand kind of at a very zeroth order level what the radiation conditions will be for them if they're flying in those zones, in the zones that they know are radiation hazards. Hopefully that helps. Okay, let's see. Does solar weather have here we go. J-Dog, does solar weather have an effect on earthquakes? Man, I answer this almost every single time I do a forecast, because so many people try to link the two. And the way that mainstream science has to look at it is the only way we can, which is we have to wait for geophysicists to quantify the geological drivers of space weather. I mean, of terrestrial weather, what am I saying? Of geophysics. The primary drivers of earthquakes are geophysical mechanisms, right? Magma, plate tectonics, that type of thing. We have to quantify that and get a grip on how to predict when and where earthquakes are going to happen with those primary drivers, so that we can subtract that off and see what's left. Okay, the residuals. What is left then are the lower order forces and drivers of earthquakes. And mainstream science won't touch it until we can quantify that. So there's a lot of speculation and there's a lot of fringe science going on. And some of it looks very promising, and it's wonderful. I mean, we can talk about mechanisms. You can understand and think of mechanisms that are, piezoelectric in that sense, or geomagnetically induced current driven. You can think of and identify forces that do exist that are space weather related, but can you then extrapolate that in a quantitative sense? No, not yet. So sadly, although I can say it, I can see possibilities for it, especially when you think of geomagnetic storms. I cannot quantitatively assess anything, and I won't go so far as to speculate, right? That's not my field, that's the fringe science field. So all I can say is fringe scientists, keep working at it. and hopefully geophysicists will be able to solve the problem well enough so that there will be low-hanging fruit for mainstream science to pick up, and people will be able to get funding to do these types of studies. Because I know lots of people who would love to do these types of studies. If space weather were absolutely were unambiguously connected, and it was shown that it was unambiguous that space weather actually affected earthquakes, space weather funding would go through the roof. So there are a ton of mainstream scientists who would love to make that connection, and yet we still can't. Not yet. Not yet. So don't think that mainstream science, mainstream space weather scientists wouldn't love to have that be true. But they're just bound to quantitative studies only. Speculative studies are studies for fringe scientists. So we just have to wait. Okay, that's the best answer I can give you. Okay. I plan on being at 90,000 feet after this. That's great. Thanks for the laugh, Leon. I appreciate it. Oh my goodness, that's funny. The winter is so warm the last 2 years. Are these flares contributing? Likely not. Solar flares are too transient, right? The sun actually affects us on longer time scales, and it's more climatology. Space weather is so transient. It doesn't have, it doesn't couple quite the same way that you might expect. And again, that's too, the subject, to be able to answer that question with any fidelity, I would need longer time. So maybe that's something, again, I do for a mini course. But for a forecast, it's intense questions. Gosh, you guys are really drilling down deep today. Anybody have questions about the forecast? Something slightly on the more surface level? What's the worst? My good, another one. Philip, what's the worst case scenario with a CME? Okay, for that one, go look at the last 4 courses I've done about Carrington class events, right? If you look, I have a series called the A series, meaning analysis. The A series is all about extreme events. And I've analyzed like 4 or 5 different Carrington class events, and I'm going to have a new mini course coming up soon, which I'm going to post a scheduling thing on Patreon here within the next few days. We're going to actually talk about that. I'm actually doing some very interesting plots that I'm putting together for that one. I won't go into the details, but yeah, that's coming up soon. So go take a look at the other 3 or 4 courses that I've done in the A series, and you will see a lot of answers, because there isn't just one answer to that question. There's a lot of answers to that question. Okay. Let's see. Thank you, MJ Parks. It says, thank you for the update, Dr. Scove. Love a good space weather video based in scientific fact. Yes, I will not overstep my bounds. I mean, I know what I'm an expert, so to speak. It's a work in progress. I know what that is in the field I'm in. I will never step outside and try to pretend I'm more than I am. But I will. But there's a very good chance that I will know people, or know where to point you to get you to see, find the right information. So there's that. And thank you, Jerry. I see that you're having to rein people in. Yeah, everybody be nice. Remember, we are all in a community trying to learn here. Okay, let's see. The MSM, for the most part, completely ignores the whole field of this whole field of research. Yes, but that's not. I don't think that's purposeful. I think that's because they're trying. They don't understand it yet. Space weather is not like terrestrial weather. You can't see it. You can't feel it very easily. So it's very difficult to report on. Plus, the language barrier is extremely intimidating for most journalists. So we have to ease them into it. And because people conflate so many different space weather phenomena together, it makes it even harder to understand. So people call a solar flare a CME and a CME a solar flare, and they think all this stuff is the same stuff, and it's really not. And so that makes it much, much harder to understand and write about it. So I think that's more the reason why they're ignoring the space weather. It's partly because it's too new, they don't really know it. Remember, space weather, the field of space weather is not even 100 years old yet. It's like 60 years old, 70 years old. It's really, really young. And it's tough. It's tough. There's not a lot of science communicators out there who are specific to space weather. So that becomes the big issue. Okay. Let's see. Any other questions on on the forecast. I see a very interesting question. Secret Owl says, can I help you do a space weather and health course? 10 years worth of research. That's coming. As a matter of fact, I've got to talk, that's one of the subjects I got to talk with my VIPs about. We're going to be having a steering committee meeting about that. Not just about that, but about some of, that's going to be one of the things that's on my agenda to talk about. So soon, Secret Owl, we'll talk about that, you know, behind the scenes. What are the chances for communications on the ham radio this weekend? Very good, I think. You'll have periodic radio blackouts, but not too much, Wendy. So you'll have to be dealing with that a little bit. But the big solar storm impacts, don't worry about it. Night side communication should be pretty good, actually, and pretty stable. When do I think the cycle will peak, Mr. T? Probably later this year. Am I thinking summer? Not quite yet. The fact that I'm seeing these coronal holes the way they are, I don't think we're quite there yet. We also have about 30 degrees of the sun that doesn't have active regions on it yet. So I think we're in the solar maximum phase, but are we at the peak of the solar maximum phase? I don't think so, not quite yet. So maybe the summer, maybe in autumn. I do think it'll be this year though. So it won't be 2025. Okay. What else? Do we have any other questions here? I'm seeing questions, but there are certain questions that I see that I don't really understand. What are the odds of solar void Earth? I have no idea what that means, Alan. What happens to the magnetosphere after it's been hit a few times? It's called preconditioning. Means that it gets very sensitive, kind of like giving yourself a rug burn. Once you give yourself a rug burn, you don't like to touch that area. Or if you have a sunburn, right? You don't like to touch that area. So think of the magnetic shield as being sunburned in a sense. It's very sensitive. So anything that comes at it after that, it makes it riled up. It's very easy to set it off again. So if you get hit by a storm and then and it creates a certain disturbance, if you get hit by another storm just shortly thereafter, that's the same size storm, don't expect the same size disturbance. Expect a little bigger disturbance. And the reason for that is because you've preconditioned that Earth's magnetic system to be stormy, okay, for reaction. Okay, you've kind of loaded it up is really what you've done. So what is the latest news on the incoming galactic dust cloud? Again, wrong channel for that type of question. That is not space weather per se. That is, you're talking about astronomy. And when people are talking about the galactic dust cloud, I hate to tell you that. That is just a current sheet, guys. It's a galactic current sheet. This is not the first time Earth has passed through a current sheet. Earth passes through a current sheet every 2 weeks. It's the solar heliospheric current sheet. So if you think that by having our solar system pass through a galactic current sheet, that it's suddenly going to cause the sun to go micronova and the Earth's magnetic field to flip, you got the wrong physics, guys. You got the wrong physics. We pass through current sheets every 2 weeks, okay? It's just a slightly more dense solar wind, and the solar wind is extremely vacuous. So having it be a little bit more dense is not going to mean anything. And the galactic current sheet is even less dense than the heliospheric current sheet that we go through every 2 weeks. So I'm really not sure what your interest, what the issue is, okay? Could it affect space weather enough for us to notice? Hard to say, hard to say. I mean, we do see differences when we're in A greater than 0 cycles or A less than 0 cycles. So when the sun's magnetic field flips from north to south or to south to north, we do see differences in the cosmic ray impact at Earth. We do see hints of what the intergalactic magnetic field direction does regarding energetic neutral atoms. So we do know, at the termination shock at the edge of our heliosphere, we do know that it does affect how cosmic rays hit us. Okay, we do know that the intergalactic field means something, but how it exactly couples into our heliosphere, it's really hard. And the intergalactic field is very, very weak. I mean, we had Voyager pass through these regions. It had a hard time measuring because they were like a quarter of a nanotesla. Earth's magnetic field, the solar wind's magnetic field at Earth is on the average 5 to 10 nanotesla, right? We have big solar storms, it's 50 nanotesla when it's a big one, right? So a quarter of a nanotesla compared to that? You know, you're talking about stuff that is just, it's almost in the noise, okay? And people are expecting these grandiose, reactions from the heliospheric system, and it's just not going to, you're going to be disappointed. I mean, I'm not going to be disappointed, but because I don't want the world to end, so I'm kind of happy that it doesn't matter. But those who are doom and gloomers and just like to sit on pins and needles and worry that the earth is going to come to an end in the next 40 years, you guys are going to be disappointed, So that's my 2 cents there. No, it's not no, Sharon, it's the preconditioning is not the magnetosphere being weakened. It's not the magnetosphere being weakened. It's being mass loaded. There's junk that the previous solar storm pumped into the Earth's magnetosphere, and now the Earth's magnetosphere is having to deal with it. This is why it creates aurora, to get rid of the energy. This is why it shoots stuff down its tail, to get rid of it. And that process takes time, right? Draining a bathtub takes time. And so if you get hit by something, or if you fill the tub up before you finish draining it, well, it doesn't take quite so long, does it, to fill it up to the top? Same kind of thing. Has nothing to do with the Earth's shield weakening. That's just not a problem, okay? All right. What we're going to fry? Yeah, no, we're not going to fry. Okay. So let me take a moment. Jerry's telling, okay, Jerry, what is it? When you talk about a hot spot longitude, given the sun is rotating, the longitude is also rotating. The longitude is also rotating, right? Okay, how come the hot spot is stationary? All right, this is a great question. Thank you, Jerry, for highlighting that one. Whoops, let me go here. Okay, actually, I can go back to the beginning. Now, let me take the chat off so that I can show this to you without it. All right, so when we talk about the solar longitudes, just you can imagine a sunspot being at a solar longitude, okay, at a specific solar longitude. So if this is, and I don't know what it is because I don't know where 0 is, because I'd have to look at a synoptic map to see exactly where 0 is. But let's just pretend region 3553 is at 0. So as it moves, helps if let's start this, please. Okay, go there. No, you went to the wrong place. Weird. Why are you doing that? Are you going to play? Okay, there we go. So as 3353 rotates, right, that longitude is rotating with it. Okay, and of course a longitude, if you were to map it, would go up to the pole and it would stretch out this way, right, and come back in like this. So when I say a vertical line, I should be very careful, because if you actually were to map that onto a sphere, yeah, the line kind of goes like this, right? It kind of bends. So I should have a grid on this to show you that. So one day, maybe when I'm during a mini course or something, I'll talk about a grid-like thing. And I'll put a grid-like thing on one of my images and show you a longitude that rotates. So, oh, wait a minute. No, I got to be careful. No, let me not talk about it that way. When I say a hot longitude, okay, I got to be careful, because I'm thinking of longitudes from the perspective of a map. This is not a longitude that's a mapped longitude. It is a region underneath the sun, and it does move. When we're talking about Rossby waves, it does move under the surface. How it moves, I don't really know the details of that. Not a lot of people, I know the NCAR-UCAR team have been doing research on Rossby waves under the sun, but if for those of you who are meteorologists in Earth, right, we have Rossby waves in the upper atmosphere all the time, and they move pretty much unimpeded, right? There's very little to damp them, and so they move around and just kind of change where they go and how they go. But they don't, I think basically friction and gravity are really the only things that end up damping them. And I don't know if that's exactly the same mechanism going on in the sun. I just don't think we know that much about them yet. So how they move, they don't move like all over the place, but they and so they're decoupled from the surface rotating, but they do slightly, they will migrate slowly over the course of days, and then sometimes they'll rise and then they'll just drop back and they'll disappear. So we don't know all that much about them. It's just that when I see a region like 3561, which is completely quiet, right? And then suddenly, oh, whoops, that was interesting. Oh, it's because I go here. Let me hold on. Let me tab it to the next. There we go. Let's go back to that. And then it starts really, really suddenly going pow, pow, pow. I mean, it's just firing like crazy over this 24 to 48 hour period. It's just that has to be a hot longitude. It's not just something is causing what we call flux, magnetic flux, to emerge in the middle of this spot and make it very unstable. And so when I see that, then I know, okay, there's probably, the main reason why we see that happen is Rossby waves underneath the surface. And so, yeah, they're moving, but they're not moving like the map, like the sunspot map longitude is moving. They're a bit independent. They migrate, but I can't really say, how well they move. So in other words, you can't map them to a sunspot and keep them on that sunspot, okay? So for a transient period of time, they will be here. And since region 3559, within a few days, is going to rotate through the same hot longitude, then I wouldn't be surprised if we end up seeing it get flare active. See how close? I mean, we're almost there, right? By the time this thing stops, I mean, I've got a few more frames before it completely stops. Yeah, so that's the last frame I had, which was just a few hours ago. So, it's not that, there's not that much more time. And so do I expect those Rossby waves to still be in the vicinity of this hot longitude? Yeah, I do. I've seen it typically maybe 2 or 3, maybe 4 days. Sometimes a little bit longer, but much of the time it's less than a week that they'll be at the same location. But I have seen exceptions to that rule. But they do migrate a little bit, okay? And that's about as best, I know that's more of a kind of a touchy-feely answer, but that's the best I can give you, because these are areas that aren't really studied all that well yet in the field, because we're beginning to blend terrestrial meteorology and solar physics. It's kind of neat. It's just a totally new field. So hopefully that. Yeah, I do use whooshes and bangs to express yourself. Yeah, I do. People say, "Oh, you just do that for effect." Like, no, if you know me, I use that. It's just me. Okay. Pete says, what would classification of a solar event MX cause? What would cause a Carrington event? Well, you can't. Oh, again, this is something from my mini courses. The answer is complicated. A flare, you're talking about flare classifications only. And although flare classifications are a good harbinger or are a good proxy for a lot of coronal mass ejection impacts, they're not the end-all be-all. So a solar flare, a big solar flare like an X-class solar flare, tells you something about the flare, tells you something about potentially the radiation storm being launched, tells you something about the radio burst and the radio blackouts you're going to get. But even if a massive CME is launched, you may not get anything, or you may get just a tiny whisper of an effect at Earth because the CME may not hit you. So, or the CME may be very wispy because it just prior to this flare, it fired another big X-class flare, and that had a massive CME. But now it fired another X-class flare, and there's no CME at all because there's no material to launch. Right? In order for a gun to fire a bullet, you've got to be a bullet in a chamber. The CME is a bullet in a chamber, and if there's no material up there that's the bullet, you can't fire a CME. Okay, so you have to be careful when you use flare classifications to talk about a Carrington event, because a Carrington event is much, much more than a solar flare. And that's why I'm talking about those mini courses, the A series of mini courses I've taught, explains about all of that, and why every time when you see a Carrington event, you've seen one Carrington event. Okay, you've not seen all Carrington events, because there are a ton of Carrington events that you've never even heard of. And Carrington events hit Earth much more often than you might believe. The reason why you don't know is because maybe they didn't affect the technology you cared about, or maybe they went unseen because they impacted something in a pretty minor way, but they were still Carrington class event, right? They still launched at the sun as a big, intense event, but they just don't have the same impact because of all sorts of different reasons. Not every Carrington class event is Carrington-like in every type of solar phenomena that it dishes out. Some Carrington events can be very strong in certain ways and very weak in others. So you have to be, again, you have to be extremely careful. And they're not the beasts to be afraid of that everybody makes them out to be. They're really not. So please, if you get a chance, watch the A series of courses, at least the first one, because you will see they are to be respected, yes. They are to be known, yes, but they're not to be afraid of, okay? And I think those courses will help you understand that. Hope everybody understands that. Okay. I personally love them. Keep them coming. It seriously helps my small brain to understand your Q&As. Okay, good. Thank you, MJ. That's sweet for you to say. Okay. Let's see. I think what I will do... oh, thanks, Jerry, for putting that up there. Much appreciated. That is what I'm concerned about. Our government has really let us down, not hardening the grid against one. You know, there are a lot of mitigations put into place, and there's a lot of good scientists. Antti Pulkkinen, for example, in the United States is huge, and has been dedicating volunteer time to this endeavor for geomagnetically induced currents and hardening the grid for, can I say decades, Antti? I got to be careful. I don't want to, let people know how your age. But anyway, and what does that say about me? Because I've been watching you for decades. So he has given so much of his time to this endeavor to do nothing but help the government understand the risks. And they have listened. They have listened to a great degree. Now, there's lots of things in the trade space that makes them make decisions that, you and I would kind of go, oh, really? And a lot of it has to do with profit. You guys know. You know how the game is played. So, are they going to make the decisions that we want them to make? No, they're not. But there are good people who are fighting the good fight to try to get all of us aware, and especially the utility grid companies. And a lot of the power consortiums, they know what to do. They know what to do, and they do it all the time. They implement mitigating strategies at a G2 level and higher. So they've learned a lot of lessons from the past. My biggest concern are smart technologies, because we don't have precedents for them, and a lot of them because they use relays and more capacitors and things, it makes the grid weaker, to be honest. It makes them more susceptible to space weather storms. And I don't think we have a handle on that yet. So that's my biggest concern, but that's for another time. All right, let me check, let me go ahead and check Patreon and see if there are any questions on Patreon. And I'll get into a very short deep dive, because you guys asked some really good questions. And I just want to show you just a few things before whoops, this is the wrong one. I want to show you a few things before I get off here. The only problem is now I have to reload Patreon. So please forgive me if the stupid thing begins to echo again for a moment. It's not my favorite platform for this particular thing, for live stuff. It can be very painful. Okay, let me see if I can go to the post, please. Boy, Patreon's just changing stuff all the time. Okay, no, do not start it. Okay, yeah, see, it tried to start the feed again. Nuts. Okay, David N., what are hot longitudes? Magnetic field related, possibly. Reference to one of Tamitha's helio or space weather instruction videos would be great. David N., I do not have a video on this yet. So, yeah, and Julie's asking too, can you please explain longitudinal hotspots? So for David and Julie, please let me know if you're in the chat, or if you're on Patreon, please let me know if my explanation of longitudinal hotspots made sense. Okay, and if not, and if you see it later or something, post more stuff on Patreon, and I'll respond to you in text or whatever. But I'm hoping that that what I talked about made sense. We just don't know enough about Rossby waves in the sun yet to really understand, but we definitely know that it is somehow helping magnetic, and when I say flux, I mean magnetic flux, reach the surface. So yes, it is magnetic. Pretty much everything in the solar dynamo is magnetic. It's dominated by magnetic fields. So yeah, so okay, now what was the other thing I was going to do? I am going to show you some fun stuff. I'm going to change this to here. And first I will not show you that image. I will show you this one. Okay. So this is the last 7 days or so, well, a little bit less than that, since about the 20th, of solar wind data. And I'll keep this kind of like this so you can maybe see the date, January 20th, 21st, 22nd, all the way to essentially the current time. Here's the magnetic field, guys. This was the first solar storm that hit us. This was the one that I got excited about and said, hey, maybe a G3. Oh my Lord, it didn't even make 15 nanotesla. And at top of that, it barely had any southward magnetic field. That's this red right here. This is 0 nano. So what I'm showing you is a time series. This is magnetic field strength and direction. The white trace is the magnetic field strength. When you see it really super low, like around 5, these are nanotesla. That's 5 nanotesla, which I told you was about the average solar wind strength, okay, at Earth. Yep, there you go. So there's 5 nanotesla. You get up into the solar storm, it gets up to about not quite 12 or so. Yeah, great, wonderful. And then it comes down very, very quickly, okay? The red line is the direction, the north-south direction of the magnetic field. I can put the others on there if I want to, the other 2 colors, but I won't because this is good enough for what we're talking about. Southward magnetic field means lower than 0. Okay, so anything below this line is southward magnetic field. If you have southward magnetic field, then you're able to have the Earth's magnetic shield, which is a magnet, and the magnetic shield of the solar storm, because it's magnetic too. It's like taking 2 fridge magnets and pushing them together. If the solar storm magnetic field is pointed southward, well, the 2 magnets will click together because they're opposite in polarity, just like fridge magnets do. If they're the same magnetic polarity, they repel each other, and so it becomes a bumper car and it bumps off. But if it's, so this would be northward magnetic field, this is southward magnetic field, this is Earth. They'll click together if the solar storm magnetic field is southward. So that's why we look for the southward component. We had a short period of southward component. Yes, there was a little bit of a substorm. Those at high latitudes got a nice little show for an hour, maybe 2. And then we popped out of it. That was it. Just the short, maybe 4 or 5 hour little blip. And that was it. And then we went back to basically just disturbed, ratty solar wind crapola until we got grazed by yet another. This might even have been another. And here was another solar storm that we got grazed by that we thought was going to be a decent hit. And now look, this is the bigger one. This is the one that we expected, well, this one especially right here, really expected it to be a decent hit. We did get hit late on the 25th, which is about what NASA said we'd get hit. So I'm very pleased to announce that NASA did a fantastic job in their forecasting, but except that they showed a much more direct hit. We just barely got grazed by this thing. So that's what's going on now, and it's pathetic. We're almost back into the solar wind. So it's like, oh goodness. We didn't even see temperature go down. The speed is pretty poor, about 400 kilometers a second, maybe even a little bit slower. So there's nothing. There's just nothing. It's a big nothing burger. So 3 storms in a row have all been fizzles, okay? So this is why I don't think NASA or NOAA is going to be correct in their assessment. I believe this was the solar storm that we were hoping were going to hit. And why do I say that? Now I'll switch to the cosmic ray. So this is cosmic rays over the past, since about the 20th, okay? I think this is starting of the 20th, and then it goes, these are hours down here. So 0100, 06, 1200, 1800, 24, 21, 24. So you get to one day and then it starts over again. So the 20th, 21st, 22nd, 23rd, 24th, and now the 25th, okay? So you can see this is 0-100 hours for each day. And what we're looking at, this is before the storms really hit and did much. We didn't, the cosmic ray level was sitting at about, 0-ish, give or take an ish. Then we got impacted a little bit. We had a radiation storm. That probably is why this rises here. I think that's why it was. And then we go down, okay? This was the first solar storm that hit us right around the 22nd, okay? This solar storm gave us this decrease. It's called a Forbush decrease. This is because the solar storm's shock wave is shielding out cosmic rays. Okay, so we can tell, even if a solar storm doesn't hit us, we can tell if there's a shock wave nearby driven by a big solar storm or a big high-speed stream, because we can see the Forbush decrease. Well, there's the Forbush decrease for the first storm. And then, yep, there's a Forbush decrease for the second storm a little bit. There's even a little bit of something for, you know, maybe a third-ish kind of ratty solar wind stuff. Kind of, it's kind of nearby, kind of not. And then sure enough, here we go. It's the lowest point we've been since this first one hit. I think this is the Forbush decrease beginning for the one that NOAA thinks is going to hit tomorrow. So I think it's going south of us, guys. I think we're just stuck with this junk. If I can get it back. Are you coming back? Oh, what happened? Hello. There. I think we're just stuck with this junk. So the main bulk of this one is going south of Earth. We're likely not going to see anything. So that's why I say next, you know, it's the coronal holes. I mean, yeah, the coronal holes with a fast solar wind is going to give us a much better showing. Okay. And that is about it, guys. Here's what our, if it comes up, here's what our conditions look like right now. Really, gosh, come on, zoom in. So here's our fast KP, so to speak. The now, oh wait, no. Well, yeah, but it's still not showing much, just kind of junk. It's not got the latest measurement in here. That's what that 0 is showing. But all we've been hovering at, you know, for those who understand KP, 3 is unsettled. Once you get to 4, that's active. We've been hovering but a 3 and below. When you're at a 1 and a 2, you're almost at quiet conditions, right? So we really just haven't seen much from this storm, sadly, and I think that's just the way it's going to be. So if you're at high latitudes, maybe some aurora, right? But at least you guys who have contests or anything like that today, you know, don't worry about it. You're gonna, or the next, over the weekend or anything like that, DXing should be pretty good outside of some of the radio blackouts periodically, okay? And that's all I've got. Hopefully you guys enjoyed this. And yeah, no, we're not all going to die. So it's just boring background for now. That's right. That's exactly, even solar wind is just boring background right now. Okay. Yeah, thanks, Jerry. Yeah, keep the topics to the space weather. We're not talking about gamma ray bursts or anything like that. Okay. So that's it, guys. MJ, you say, thank you, Dr. Scott, for the update. Saw that even the news was reporting and wanted to see what was up. Your video was awesome and welcome. Yeah, this is why I wanted to come on, because, you know, all of the space weather forecasters, we really thought that we were going to be getting something. And so I wanted to make sure I updated you guys to let you know, so that you're not out at night staring at the sky going, you know, where's the aurora? It's not coming. And if I'm wrong, oh my gosh, it will be so great. That's why on my 5 days I have, you know, once again, if I can pull that up again, I have on my 5 days that we're on storm watch, right? Especially for high latitudes. Let me pull that up one more time for you. And I'll leave that as my final screen here. There we go. So I'll leave that there. I can pull up the chat one more time, but I think everybody's probably tired. I've been on here for a little bit more than an hour. So hopefully you guys have gotten all the information you need. And you're very welcome, J-Dog. Thank you for explaining the NOAA charts. Makes more sense now. Good. You're very welcome, guys. Okay, so enjoy and relax, and don't worry. Nothing crazy is happening. Everything is nice and calm. And, you know, just wait for that fast solar wind, right? Because we'll get a better chance for some storming conditions with that. At least we know coronal holes send fast wind. We don't have to worry about them missing us when they're in the positions that they are. We pretty much know that they're going to be sending some fast wind. But again, I don't know if at mid latitudes if it's going to be enough to give us something. But high latitude should be pretty good. Okay, all right, guys. Take care. Have fun. Yeah, please definitely go off to watch the courses. Yeah, those the A-list course. The A series is for Carrington class events, the extreme events. You'll learn a lot about it. And hopefully by the end of even the first course, you will feel so much more calm when it comes to Carrington class events, so that anybody on YouTube talks about them, they're not going to make your heart leap into your throat, because they're just not. They're not the beasts and the scary monsters that we make them out to be. They are to be respected, but they're not the planet killers. Okay, so all right, and with that, I'll let you go. Okay, bye guys.